Good day! We're going to go over our Polygon study guide as part of our preparation for the Unit 12 summative. To begin, we have to make sure that we know the names for all of the polygons from 3 sides up to 12 sides. 3 sides is a triangle, 4 sides is a quadrilateral, 5 sides is a pentagon, 6 sides is a hexagon, 7 sides is a heptagon, or sometimes you'll also see it referred to as a septagon. 8 sides is an octagon, 9 sides is nonagon, 10 sides is a decagon, 11 sides is an undecagon, and then 12 sides would be a dodecagon. So be sure that you're familiar with that vocabulary. Next up, if I give you various information about a polygon, can you determine other missing information for it? So in looking at this, hopefully you recognize that the total exterior sum of the angles should be the easiest thing for us to fill out. The exterior sum is always 360 degrees, no matter what. Most students would probably say that it's easiest to begin with knowing the number of sides. So then when you find that total interior sum, that's where you're thinking about your quantity of n minus 2 times 180. So dealing with 12 sides there, that would then put us at 1,800 degrees for that interior sum. Now, if it's a regular polygon and you want to know one interior angle of that, we're going to take that sum and divide by how many angles it has. So I'd be looking at 150 degrees in each of those. And then the last detail to find that one exterior angle, remember that one interior angle and one exterior angle together always have to make a linear pair. So they always have to have a sum of 180 degrees. So if I've got 150, then I can easily find out that my one exterior angle would be 30 degrees. So I'm going to use that detail again about the interior and the exterior angle as a linear pair on that next row. If I'm told the exterior angle is 15, then I can find the one interior angle for us to get that 180 sum would be 165 degrees for us. I can use that again when I know one interior angle is 135, complete the linear pair, so that one exterior angle would have to be 45 degrees for us. So we're working our way through. Now, to find out about the number of sides, this ends up not being too bad when you know that one exterior angle here. Since we know that there's always that 360 total, we can divide this by our 15 degrees, and that would tell me that I have 24 angles, likewise 24 sides. Also, I can do the same thing with my 45. 360 divided by 45 tells me how many angles that I have. That's going to be 8, so also 8 sides. When you know these, then it's pretty easy to find that interior sum again, doing that formula n minus 2 times 180. So 24 minus 2 puts us at 22 times 180. So we're looking at 3,960 degrees. And if you have 8 sides, then you're thinking n minus 2 is 6 times 180 would put you at 1,080 degrees for it. So lastly, if you know the interior sum of 2,340, you have to do a little bit of equation solving for this one. That 2340 is equal to this n minus 2 times 180. So I go ahead and solve that equation. I divide both sides by 180. That's going to put me at 13 is equal to this n minus 2 now. So I have to add 2 to both sides to find out what my n value is. 13 plus 2 puts us at 15 for n for my number of sides. Now that I know the total and the number of sides, we can simply divide those to find my one interior angle in a regular polygon. That is setting us up here. We've got 156 degrees for that. And once I know that, complete the linear pair to find out about one exterior angle. You're looking at 24 degrees. You could have also done that with your 360 divided by the number of sides, also still gives you 24. So in that next section, we're looking at concave versus convex. And so in that first image, is this a polygon? Yes, it is. Is it concave or convex? This one is concave because you can see where it caves in. It has something that has pushed it in, so it's not fully ballooned out. But count the number of sides: 1, 2, 3, 4, 5, 6 sides. So that would make it a hexagon. In part B, is it a polygon? Why, yes, it is. Concave versus convex. This one is convex. It is fully pushed out and inflated. 4 sides there. We would call this a quadrilateral. In number 5, yes, we do have a polygon. It's a closed figure. It does happen to be concave because you can see where somebody has poked this shape in, and so it has some dents. However, when you look at that, count up those number of sides: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 sides makes that a decagon. Certainly not the kind of decagon that you are used to seeing, but it is nonetheless. Part D, yes, we do have a closed figure for a polygon, and yes, it is convex for us where it's filled out. These 6 sides might be what you're more used to seeing for a hexagon. When you get to E, no, this is not a polygon. It's not a closed figure. It crisscrosses and overlaps itself, almost makes it look like it forms 2 figures. The last one, part F, yes, we do have a polygon, and it is convex, where it looks like it is inflated and ballooned out. There are 5 sides on that, I hope you see, so that we can call this a pentagon. So, moving into some more of these calculation style problems, how many sides does a regular polygon have if the exterior angle measures 24 degrees? So, I know that an exterior angle of a regular polygon, exterior sum is 360 divided by the 24 degrees that we have, and that will simply tell you the number of angles. So, we're talking about 15 angles, which likewise also means that there are 15 sides. On that number 5, looking for how many sides do we have when the interior angle sum is 5040. So this one again, I would think about my formula, n minus 2 times 180 equals this total 5040. So I'm going to divide both sides by 180 to help me solve this. So n minus 2 then is equal to 28. I'd add 2 to both sides, so n is equal to 30. So there we are talking about 30 sides in that figure. In this 6th problem, how many sides we're trying to figure out does the regular polygon have if each interior angle is 168.75? For me, I'm going to convert this into an exterior problem because I know that that interior plus that exterior angle has to equal 180 degrees for the linear pair. So with that 168.75 as my interior information, adding on my exteriors would give me that 180 total. So let's subtract from both sides and find out that the exterior angle in this problem must be 11.25 degrees. Now, this is very similar to the 2 problems that we had ago. If I take that 360 and divide it by the exterior angle measure on that regular polygon, that's going to tell me that I have 32 sides. 7, asking for the measure of each interior angle on a regular 10-sided polygon. So I would take my, well, you could do this 2 different ways. I can take my 360 as my exterior total and divide it by 10, find out that I have 36 degrees as my exterior angle. Then go ahead and convert that into an interior angle, again using that interior plus exterior as a linear pair idea so that they have to equal 180. So what is that interior measurement that I can add 36 to and get 180? That would be 144. So that's one option that you could have to solve. The other thing that you might do is if you recognize, right, that your n minus 2 times 180 formula gets divided by the number of sides to get you there. So then I'd be taking my 10 minus 2 times 180 and dividing it by 10 for a little bit of arithmetic there. So that would be then a numerator of 1,440 divided by 10 puts me at 144 degrees. So either way that you choose to think about it, you're going to get that same answer. Number 8, I've got interior angles in a convex decagon given to me. So this is going to be a little bit lengthy for us. We're going to have to add them all together, the 150 and the 145 and the 130 and the 34x and the 35x and the 135 and the 160 and the 120 and the 30x and the 21x. Good, we've got them all added together. And now this is a decagon, so it's going to be equal to this 10 minus 2 times 180 sum. So overall, it's equal to this 1,440. So I've got to combine some like terms here. So I'm looking at my variables. I've got a 34, a 35, a 30, and a 21 that we are adding there. So that's 120x. And then as for my constants, 150, 145, 130, 135, 160, and 120, that's giving me 840. So as I continue solving, I'm going to subtract 840 from both sides. This is putting me at 600. Divide both sides by that 120 constant, and x is equal to 5. But I want to know then the smallest interior angle. So let's see. I'm going to check out my variables. Which one of those variables is most likely to be the smallest? Probably the 21x. So let's check that out and see if it's smaller than any of the numerical values. So 21 times 5 is 105. That is, in fact, smaller than any of the constants that we are given, so that is the smallest angle. Then, for the number 9, kind of a similar idea there for you. Measures of exterior angles in that convex hexagon. But since we're talking exterior angles, we can add these together. 45 plus 60 plus x plus 3x plus 7x plus 90. Add those all together, and the exterior total is going to be 360. So I'm going to combine some like terms. X, 3x, and 7x makes 11x. And with the constants 45 and 60 and 90 puts me at 195 to equal our 360. Let's subtract the 195 from each side. So if 11x is equal to 165, when you divide by your coefficient of 11 on both sides, x here is equal to 15. We are asked to find the largest exterior angle. So I'm going to go ahead and plug into my variable. 7x would probably be the largest variable. Let's find out if that is bigger than any of our constants. And it turns out that 7 times 15 is 105. That is bigger than the 90 we had, so 105 degrees is the largest angle. So in this number 10, trying to solve for x and y, when you look for x, I hope you recognize that that is an exterior angle, so it's going to be a linear pair. So my x and my 136 together have to equal 180 degrees. That means x must be 44 degrees. When I turn around and go to find y, y is dealing with these exterior angle measures. So the 70 and the 82 and the newly found x, that's 44, along with my 6y minus 7 and my 6y plus 3, all of those together have to give me 360 degrees for my exterior angle measurements. So we will do a little bit of subtraction and calculations with these. And as we solve then, y is equal to 14. Now when we look at 11, trying to find these exterior and interior angle measurements of a regular polygon. So my exterior is going to be 360 degrees divided by the 6 exterior angles that you have. And that calculation nicely comes out to tell you that y is 60 degrees. For our x, notice that we're going to take the number of sides minus 2 times 180 to find that interior angle sum, and then I will divide it by 6 to evenly spread those amongst the 6 interior angles. This is going to put us with that x value as 120 degrees. Also, you might have realized that x and y, even though they're not next to each other, if it is a regular polygon, every interior angle should have the same x measurement. So make sure that your x and your y are, of course, a linear pair and that they have a 180 total. Number 12, to solve for this x and y, we're going to need to set up those equations again. Think about that. So I've got a 90 and a 160 and a 91 and a 94 and a 149 and a 7x plus 3, all of them together that have to total, let's see, 1, 2, 3, 4, 5, 6 sides. So 6 minus 2 times 180 gives me a total of 720 degrees in here. And so some great calculations and wonderful algebra then that have to go on as we are solving this. And go ahead, combine those like terms, subtract from each side. Coming out here now that x is equal to 19. We will plug that back in now. So 7 times 19 plus 3 lets us find this interior angle at 136 degrees. And we can recognize then that we have a linear pair. So my 3y plus 8 along with this 136 that we just found together need to make 180 degrees. And if we solve for that, y is 12, so that we can have that exterior angle as 44. In 13, we've got some polygons shown here. Recall that at any singular point, you should have 360 degrees the whole way around. So in this regular pentagon that I'm looking at, I'm going to think about 5 sides minus 2 times 180 and dividing by 5. So that will tell me that my my interior angle here that I'm looking for is 108 degrees. In my triangle, it's again a regular triangle for us, so I'm going to think about 3 minus 2 times 180 degrees divided by 3. So that would give me 60 degrees for my triangle angle. And then lastly, I'm going to come look at the hexagon over here. So 6 sides minus 2 times 180 and divide that by 6 so that we can share equally amongst all these angles. You're talking about 120. So to get the 360 degrees all around, what is this x measurement? Well, let's put it with everything else that we have found to get this 360 total. And we're coming out with our x as 72 degrees. Lastly here, as we look at number 14, I want to find that interior sum, so 62 and 7x plus 15 and 105 and 88 and 6x minus 2 all together have to equal, let's see, 1, 2, 3, 4, 5 sides. So 5 minus 2 times 180 gives me a 540 total. We're going to go ahead then and solve for that. Combine some like terms here. And so my x value out of that is a decimal actually in that case. That comes out maybe as 20.9 if you'd wish to round that. We're going to plug this in to find our interior angle with the 7x plus 15. So 7 times this 20.9 plus 15 would leave us at 161.3. And then I hope you see that your interior and exterior angle have to be a linear pair. So we'll make sure that they have 180 total, which means that y is going to be 18.7 degrees. I hope that you're feeling a lot more comfortable and confident now with solving all of your polygons. Have a fabulous day!